subtracting. Very good. And again, as you read it left to right. So I'm going to go ahead and share my screen, and I have a specific problem. We're not going to do all of these. Let me get all this stuff out of the way here. So I want you to do, where is it? Oh, I had it. Where is it? Oh, here we go. Number 3. So go ahead and do number 3. You know the process. There's no grouping symbols. There's no exponents, so you're good to go. So go ahead and do number 3, and then put in the chat your answer. And hopefully at this point, everybody's going to have the exact same answer. And anything in the OneNote is for your practice. And we're just going to do a couple of them. When I'm sharing my screen, can you guys see when I pull up the chat? Do you see all the answers too?
No.
You don't? Okay. All right. Oh, we are doing good. Yay. Okay. So I have every single answer says 16. So let's double check. So we have 10 divided by 2 times 3. So again, left to right, division comes first. So 10 divided by 2 is 5 times 3 minus 2 plus 3. And then we're going to do our multiplication. And then now it's all addition and subtraction. We see the subtraction first. So we subtract the 2, and then we add the 3. Hooray! Every single person got it. That is awesome. All right, let's test your skills. Now let's add in some brackets and braces and exponents. Number 10. And then we're going to move on. And then go ahead and put your answers in the chat when you think you got it. And this one has a lot of negative signs, a lot of minus signs. So make sure that you're double checking those negatives. Is Douglas, are you here today? Douglas Polanco? And Catherine Silva, are you here? And Santiago? Okay. Hey, Mark, are you any relation to Catherine? You both have the same last name.
No, ma'am, I'm not.
Oh, okay. You never know. I've had husband and wife in the class before, so you never know. Okay, so I have one answer so far. I'll wait a few more seconds. I know this is a long one. And there's lots of exponents, lots of subtraction signs. So while we're waiting, I'm just going to kind of start on this, and you keep going. These are the types that you have to be really diligent. So Franco, I'm going to trust that you're watching me. Making sure I'm not making any errors. Everyone good so far? There it is, 83. So we had several 83s. So if you didn't get 83, a really good way to track is if you do every step, right? As I go through, if you notice, I'm going down and I'm sifting everything down to where I have one answer that's going to spit out as 83, right? So it all gets sifted down. As you're looking, you can work backwards and go, okay, this makes sense, this makes sense. So you can kind of figure out, all right, where did I make my mistake? With a lot of negative signs, that's usually where the mistake is made. Maybe you dropped a negative, or maybe you didn't have a negative, or maybe you added a negative in. So it's really easy to drop those negatives. Any questions on that one? And we only had three. Okay, we had quite a few. 1, 2, 3, 4, 5 people that attempted this. Did the rest of you attempt it, or did you just give up because it was just too big? Be honest.
I tried, but I made it like halfway through.
Okay. How far
Before,
did you
so.
get? How far did you get down?
I got down to the braces. I got
Okay.
like the parentheses and brackets. So.
Okay. So inside each set of brackets, did you get those 2 answers that I got?
Yeah,
Okay.
I got that. I was still trying to work through it though.
Yeah.
So.
Yeah. Okay. I know. And sometimes it just takes more time than what we have in class. But I love doing big ones like this because it shows you how much you've improved. Because remember at the very beginning on Tuesday, we did those real basic ones and there was, 4 or 5 different answers. And now we have a really big one and we just have, a good set of answers and we know which one is the correct one. So that's really good. Gotcha. So Mia says she messed up on the exponent and that's super common. Just remember exponents are always repeated multiplication. And then one little reminder, if you had -3 in parentheses squared, that means -3 times -3, which is a +9. If you have the opposite of 3 squared, that's without parentheses, that's literally what that minus sign is saying, is the opposite of 3 squared. So you have the opposite of 3 squared, which is -9. So those parentheses make a big difference. If you input this into your calculator, notice if you don't have parentheses around that -3, it's going to spit out as -9. So really get used to using the parentheses. On this TI-30, the parentheses are right above the 8 and the 9. So get used to using those. It really does, it does help in getting the right answer. Okay, we can move on. All right, so homework 2 is all about fractions, decimals, percents. So the best way to get really good at fractions is to be able to divide and multiply quickly. So with fractions, that whole idea of simplifying is all it is just division. So if you can pick up how numbers are divided quickly, you are going to be so much better at simplifying fractions. So there's rules, they're called divisibility rules. And I've been shocked at how many people don't know these. They know some of them or they've never seen some of them, but man, they make all the difference in the world when you're trying to reduce a fraction. So does anyone know when a number is divisible by 2? What kind of numbers do you have? So think about
Like
numbers
even
that are
numbers?
divisible by 2. Okay, I see even. Okay, is that what you said? I didn't know who answered that.
Yes, that's what I said.
Okay, so all even numbers are divisible by 2. That means their last digit, the digit that's sitting in the ones column, has to be 0, 2, 4, 6, or 8. Otherwise, 2 cannot go into it. So that's pretty obvious. That's a really easy one. What about 3? How do you know when a number is divided by 3?
An odd number?
Okay, that's a good guess, because 3 is odd, so that kind of makes sense. If 2 is even and it's all even numbers, 3 is odd, so that does make sense. Has anyone ever heard of sum of the digits is divisible by 3? So here's an example. So let's say you had 345. Okay, I look at this number and it is odd, right? It is an odd number, but that's not necessarily gonna work every single time, because I could have, 23. 23 is an odd number, but 3 can't go into it. So what you do is you add the digits. So I'm going to go 3 plus 4 plus 5. When I add those, I have 7 plus 5 is 12. Well, 3 can go into 12 evenly, right? It goes in 4 times. So 3 can be divided into 345 evenly, because the sum of the digits can be divided. So 3 goes into 3 once. Man, it's been a long time since I've done long division. Bring down the 4. 3 can't go into 4. Bring down the 5. 3 can go into 45. Oh, sorry. See, I haven't done a long division by hand in a really long time. Okay, bring down the 4. 3 goes into 4 one time. Wow. Now I bring down the 5. 3 goes into 15 5 times. So if you can add the digits up and 3 goes into it, then we're good to go. Okay, then 3 can go into the whole thing. So if I had, let's say I had, get this out of the way. Let's say I had 12,042. Okay, I can look at this and go, okay, if I add the digits up, 1 plus 2 is 3, plus 4 is 7, 8, 9, right? So 3 can go into 9. So I know for a fact that 3 can go into this evenly. And it just makes it a really quick check. That's all this is used for, is just a really quick check on being able to divide quickly. Okay. 4 is a little bit different. It has to be the last 2 digits are divisible by 4. So a number like 428. Since 4 can go into 28 7 times, 4 can go into this whole number, 428 evenly. So that's a real easy one. What about 5? Do you know what the rule is on 5? Can you give a guess?
Is it like the last digit is a 5 or a 0?
Perfect. Last digit is a 5 or a 0. Perfect. Okay, so 5 can go into anything that has a 5 or 0 at the end. So 345, 5 can go into it. All right, so there's multiple numbers that can be divided into some of these values. 6, when both 2 and 3 can be divided into. Okay, so it has to be even, and the sum of its digits have to be divisible by 3. So it's got to be both for 6 to go. 7, unfortunately, no rules. 7, you just got to try it. That's all I can tell you. 8 is last 3 digits, 3 digits divisible by 8. So that doesn't help us a whole lot, but maybe for some values it does. And then I'm going to start moving a little faster here. 9, when sum of the digits is divisible by 9. Okay, so this value over here, this 12,042, the sum of the digits is 9. 9 can go into it evenly, so I know 9 can go into the 12,042. With 345, the sum of the digits was 12. 9 cannot go into 12, so 9 can't go into 345. Okay, so it's just a matter of making sure that the sum of the digits can be divisible by 9. And then the last one is the last digit is a 0. Right, so we know that 10 can go into it when the last digit is 0. Okay, so where does this come into play? So there's something called prime factorization, and prime factorization is just a way we're going to stick with these numbers, a way to break this value up so that I have all the prime numbers that when I multiply those prime numbers together, I'm going to get the 345. Okay, so I can use these divisibility rules to break this up really quickly. So I know 3 can go into this because the sum of its digits is divisible by 3. So this is where you can use your calculator, right? So sum of the digits, 5, 6, 7, 3 can't go into that. 9 can't go into that. The last 2 digits, 4 can't go into 15. It's not even, so 2 can't go into it. So what number could go into this? How could I break this 115 up? We have a 5. The last digit is a 5. So what can go into that evenly?
5.
5. Good. Okay. So here we go. 5 goes into 11 twice. Bring down my 5. 5 into 15 goes 3 times. And 23 is a prime number. So the prime factorization of 345 is 3 times 5 times 23. Every single one of these numbers is prime. And remember, prime just means that you can only divide it by 1 in itself. So there's no other values that can be divided into 3, 5, or 23 except for 1 in itself. So that's the idea of prime factorization. And you're going to use that when you're looking for, a common denominator. Now, we won't need to be that extravagant, but it's a really good trick when you're working through some of the problems and you're trying to find out how can I reduce these fractions quickly. Okay. All right. So, and again, you guys can come back to this, these notes and take a screenshot of it, whatever you need to do. All right, so we're going to kind of, skim over this. So again, you can come back to it because I definitely want to get through all of 2 and 3. Actually, I don't need to get through all of it. No, I do, because Tuesday is when the assignments are due. So, okay. Give me, so you can write this in the chat. Give me 2, or we'll just do 1. Give me 1 example where you use fractions in real life. Just go ahead and write it in the chat. One example when fractions are used in real life. Because you do use them. Baking, cooking, half a dozen, all based on food. I love that. Woodworking. So Adam, can you explain that a little more? If you're talking, Adam, we can't hear you. I'm interested in your woodworking example. Don't be shy. See, if I was in a classroom, I'd go right up to you and say, now, what did you mean by woodworking? Okay, buying groceries. Jump in, Adam, anytime. Measuring, that's a good one, Brianna. Finding the right tool for the job, very good. Measuring, cutting, 1/4 off, good. Tipping, very good. Splitting a bill, very good. So you can tell that fractions and decimals kind of go hand in hand, right? A fraction is just another way to write a decimal. A decimal is just another way to write a fraction. So the fraction bar definitely represents division. That's what the fraction bar is. So if I had a fraction that looked like this, it's a fraction. It's top heavy, but it's still a fraction. All this means is 12 divided by 3. If I had a fraction that looks like this is 1 divided by 3, which as a decimal is 0.333, and it keeps on going forever. So the fraction bar is just division. So if you can get that in your head, it kind of makes fractions much easier to deal with, because all you're doing is you're doing division. Is this a true statement? The number on top of the fraction is the denominator.
No, the bottom is the denominator.
Good. The bottom or the down number is the denominator. So what is the top number called?
Numerator.
The numerator.
Good. Numerator. All right. So I feel like we can move forward. An improper fraction is less than 1 or more than 1. What's an improper fraction?
It's less, right?
So improper. So improper, this right here would be considered an improper. This right here is considered a proper fraction. So an improper fraction is actually more than 1. Okay, so that would be a false statement here too. So it's actually more than 1. So if I had, 19 divided by 7, when I do the division, 7 goes into 19 twice. That's 14 with 5 left over. So it's always going to be larger than 1 when it's an improper fraction. And then you just saw how I converted it to a mixed number. So this is considered improper. This is improper. This is mixed because you have a whole number and a fraction. And the only way you do it is you just do the division. You divide the numerator by the denominator. So again, we're going to change this. You divide let's see, let me read it. The denominator to the whole number, then add the product. I don't like this one. We're going to get rid of this one. That's way too many words. Okay. To convert a mixed number. Oh, okay. It was going backwards. Got it. So we're doing an improper fraction to a mixed number. In order to do a mixed number back to an improper, you're going to multiply. 7 times 2 is 14, and then add. So that is correct. So you multiply and then add. Multiply and then add. So if I had 1 and 1/6, I multiply. 6 times 1 is 6, plus 1 is 7/6. So the denominator will always stay the same. Okay. All right. So real life examples. You have 25 questions on your test. Susan got 17 right. What fraction of the questions did she get right? She got 17 out of 25. So if this was a test, that would be her score, and then we could change that into a percent. What did she get incorrect? So 25 minus 17. So she got 8 incorrect out of the 25. So you can see the bottom number is going to always be the same. It's the top number that changes. Okay. And then Derek bought a pack of M&Ms, counted how many of each color: 13 red, 15 green, 8 brown, 11 yellow, 10 orange, and 12 blue. What fraction were yellow? So yellow is on top. And then the total number of fractions is going to be on the bottom. So you're going to add the 13 plus the 15 plus the 8 plus the 11 plus the 10 plus the 12. So we had 11 out of the 69. Thank you. Okay. Oh, thank you, Franco. Yeah, so this is the correct ones. This is the incorrect. Okay, so bottom number is always the total. Top number is always the part, every time. Okay. All right, so we already know about improper fractions. It's just another way to say improper fractions. Improper, sorry about my handwriting, fractions. I say top heavy. Still a fraction. It just means it's heavy on the top, which means it is a, I forgot what I was going to say. Improper fractions, it's top heavy. So it means it's more than 1. It's a larger number. Okay. All right. So we're going to skip down a little bit. Any questions so far? Everyone remembering all of this good stuff? Okay, so whenever you're simplifying fractions, when you see the term simplify, what you want to switch it in your head to is, how do I divide evenly? Okay, that's what you're doing. When you're simplifying, you're making it to its simplest form. And so what that means is there's a number that can be divided evenly. So when you look at these two numbers, and this is where our divisibility rules really come into play. When I look at 15 and 25, what number right off the top do you know will be divided evenly into both of those numbers? What can I divide both top and bottom by? Good. Everyone's saying 5. Very good. So if you notice, if I divide top and bottom by the exact same value, what I'm actually dividing by, I'm actually dividing by 1. 5 over 5 is just another way to say 1. So I'm not changing the value of it. I'm just changing it how it looks. That's it. I have 2 different names. I have Robert and Bob. They are the exact same person. Robert is written differently than Bob. Exact same person. 15 over 25 is going to be written differently than my new simplified fraction. Okay, so 15 divided by 5 is 3. 25 divided by 5 is 5. 3/5 is exactly the same as 15 over 25. Just different way to look at it. Okay, all right, what about number 17? What can I divide by? Okay. 4. So remember, it's got to go in evenly to both 28 and 42. So 4 would go into 28, but 4 would not go into 42.
It would be 7, right?
Yep, good. So we can use 7. So what else could I have seen though? What else? I mean, just right off the top, I have 28 and 42. What kind of numbers are these?
Even numbers.
They're even numbers, right? So if you don't see the 7, you can look and go, okay, they're both even, so I can divide by 2. So you can simplify in small steps. You don't have to simplify all at once. So if I divide by 2, I get 14 out of 21. Okay, now these numbers look a little more familiar, right? So now I can divide this by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. So 2/3 is exactly the same as 28 over 42. So it doesn't have to be the greatest number. You can do it in small increments and still just keep going until you can't reduce it anymore. So simplify is dividing evenly. It's also another term to say reducing. Okay, now let's jump to we already did 5, so we know 5 can go into there. So let's jump to 19. When you look at this, here's a really super easy way to simplify this real quick. You see how there's 3 zeros on top and 3 zeros on the bottom? If I just cancel these, right? I take 3 off the top, 3 off the bottom. Now I have a much easier number to work with, right? As long as I take the same number of zeros top and bottom, then we can do that all day long. And really what you just did is you divided by 1,000. We just knocked those zeros off by dividing by 1,000. Okay, so now we have 24 over 39. Anything that we can use those divisibility rules? Is there anything that will go into both of those? Okay, I see a 3. So 2 plus 4 is 6. 3 will go into 6. 3 plus 9 is 12. 3 goes into 12. Perfect. So we know we can divide by 3. So 24 divided by 3 is 8. 39 divided by 3 is 13. Yeah. Yep. And 13 is prime. So you're done. That's as far as you can go. That's simplified to its lowest term. But what's nice about knocking out zeros is now it cleans it up a little bit real quick, and you don't have to think too much. Okay. Any questions on reducing? All right. Down in your reactions, give me a thumbs up if you feel like I got reducing, I'm good to go. So you hover down at the bottom and there's a reaction and it says that you can give me a thumbs up. I want you to start using the tools in Zoom. Okay, thank you, Dylan. Can you find it? Good, Robin. I can't see everybody. It drives me nuts. Isabel, can you give me a thumbs up, thumbs down? If you're not good with reducing, you can give me a thumbs down. I'm okay with that too.
I already sent a thumbs up.
Did it go away already? I missed it. Okay. Yeah, it's hard to see. I can't see everybody at once. So, bear with me. Okay, so we're going to start doing operations of fractions, and then we're going to move into decimals and percents. So whenever the easiest operation with fractions is multiplying and dividing. There's 2 different techniques to do with multiplying and dividing. The first technique is, I'm going to do it over here. The first technique is you take your number, you take your 2 fractions, and you multiply straight across, right? 1 times 3 is 3, 2 times 5 is 10, 3/10 is your answer, and you're good to go. Now, what I like to do is I always like to see if there's anything that I can, what's called cross-canceling. And cross-canceling is you're reducing before you multiply. So when I multiply straight across here, I can see 3/10. That's simplified. That's reduced down to the lowest term. So there's nothing else I could do. But if you look at number 21, 21 is -2/5 times -10/3. Okay, if I multiply straight across, which there's nothing wrong with that, you can do it this way. If I multiply straight across, I'm multiplying, so now your integer rules come in, a negative times a negative, so it's a +20. 5 times 3 is 15. If I just multiply straight across, now I have to reduce. right? Now I have to work through, okay, what do I divide both into, 5? So 20 divided by 5 is 4, and 15 divided by 5 is 3. Now it's reduced to its lowest terms. And a negative, that's equals, not a negative sign. A negative times a negative is a positive. So that there's nothing wrong with doing it this way, just straight across and then reduce. But what I like to do, I like to reduce before I multiply. If I reduce before I multiply, then I am good to go. I don't have to think through any big numbers and use my divisibility rules. So with cross canceling, and I'm going to write this here. And you guys choose, you decide which way you like and you stick with it, okay? Here's cross canceling. Any top with any bottom. So I have a -10 and a 5, right? I know that 5 goes into both of those evenly. So 5 goes into itself once, 5 goes into 10 twice. There's nothing I can divide into with the 2 and 3, so I'm good to go there. So now I'm just going to multiply straight across. So what cross canceling does is it reduces first, and then I can just multiply straight across. So in essence, I'm saving myself a step, right? They are both correct. You do not have to choose one over the other. I just like cross canceling because look at number 24. 24 is 150 over 99 times 44 over 75, right? If I multiplied straight across, I'd get 150 times 44 is 6,600, and 99 times 75 is 7,425. Way too big of a number. I don't want to have to deal with this, right? I don't like these big numbers. So if I cross cancel first, watch what happens. I'm reducing my fractions first. Any top with any bottom. So 44 and 99, what goes into both of those evenly? Anybody? How about 11? Anytime you have a double number, 11 always goes into it. So 11 goes into 99 9 times. 11 goes into 44 4 times. So now I'm good, right? I can't reduce anymore. And now I'm going to go to the 150 and the 25. Any top with any bottom. So I know I could do 5, but it's going to take me a few steps. So I look at this as money, 75 cents, $1.50. A quarter, right? So 25 goes into 75 3 times, and 25 goes into 150 6 times. Okay. But again, look at my numbers. Any top with any bottom. I can do it again. So I can cross cancel as many times as I need to where I can't cross cancel anymore. So 3 goes into itself once, 3 goes into 6 twice. And then I look again, is there any top with any bottom that I can cross cancel? And it's all good. So as soon as I'm completely done cross canceling, reducing those values, now I multiply straight across. 9 times 1 is 9. And there is my answer. So you're doing all of your reducing first. And it just saves a lot of time. You get real good at it. So just remember, any top with any bottom. Okay. All right. And Franco, if you see in the chat someone has a question, you jump in, okay? Jump in and answer their question or stop me. Okay.
Gotcha.
Oh, go ahead.
Oh no, I was just saying, I got you.
Okay. Gotcha. Okay. All right. So that's multiplying, right? So division, there's one step added. All you have to do is flip your second fraction first. And then you're just back to multiplying. So it's 12 over 13 times 26 over 11. Okay, so you just flip this second fraction over, and now you're back to multiplying. So flip and multiply. So again, here 13 goes into both of these, 13 and 26 evenly. So 13 goes into 26 twice. And now I can multiply straight across. 11's a prime, so there's nothing else I can do. Now, don't be afraid of improper fractions. This is a perfectly good answer. You don't always have to change it to a mixed number. You can leave it as an improper fraction. Okay. Any questions yet? And again, I can't, if you raise your hand, I can't see you. So Franco, you get to, spot that for me. All right, so we'll do these last two divisions. So if you have a whole number, you're going to put that over 1. I'm going to flip this one over, keeping the sign. I'm going to cross cancel because I have zeros on the end. So 10 goes into itself once, 10 into 1, 10 goes 11 times. So I have a negative 11 or 7 over 11. Okay. And then the last one, again, 25 is a whole number. So I'm going to write it as 25 over 1. So the first one stays the same. I multiply and I flip the second one. So I have negative 15 over 4 times 1 over 25. Okay. And then I'm going to cross cancel. So 5 goes into 15 3 times, 5 into 25 5 times, and now I multiply straight across. So I get a negative 3 over 20. So be aware of the signs because you will always have integers thrown in at you. Okay. All right. So how do we make fractions have a common denominator? Because when we jump to adding or subtracting fractions, you have to have a common denominator. And the reason for that is you have to have the same size pieces. So if I took this little square here and I broke it up in half, I have 1/2 here and 1/2 here. And I took this exact same square and I broke it up into fourths. And you're going to pretend that these are all the exact same size, right? So I have a fourth, a fourth, a fourth, and a fourth. These are different size pieces. I can't add those together. It's like trying to add, apples and watermelons. They're two different size fruits. You can't put them together. So whenever you add or subtract, you have to have a common denominator, which means I'm creating a fraction to where the pieces are the same size. So if I am adding 1/2 and 1/4, if this is my fraction, I need to rename this 1/2 where it's the same size pieces. So really what you're doing is you're taking a bigger piece and you're breaking it up into smaller pieces. So this 1/2 is actually 2/4 because if I broke it up, right, and made this into fourths, now they are the same size pieces. So I have 2/4 here plus 1 more, I end up with 3/4. So visually, it works well, right? We can see, oh, two of the fourths makes up 1/2. And so I can rename it. But how do you do it mathematically? So mathematically, we go back to our divisibility rules and multiplication. So whenever you're adding or subtracting fractions, you have to have, with unlike denominators, you have to change the denominator. You have to make it so it's the same thing so that you have the exact same size pieces. The way I do it, easiest way, you don't have to think too much, is I just multiply the numbers, right? 5 times 7 is 35. That's my new denominator. Okay, what did I multiply the 5 by? I multiplied it by 7. So I have to multiply the top by 7. Do you see, once again, I'm multiplying by 1. 7 over 7 is just 1. And it's very powerful because it can change 2/5 into 14/35. Exact same value, exact same size piece that we're looking at. It's just it just has a different number of pieces in it. And then same thing here. What did I multiply the 7 by to get 35 on the bottom? So I have to multiply by 5 on top. So 4 times 5 is 20. So 14 and 20, you only add the top. The bottom always stays the same. You never, ever, ever add or subtract the denominator. That will always stay the same. Okay, that's the easiest way to get a common denominator. Just multiply the fractions. That's the easiest way. Okay, so if I do the same thing here, 9 times 6 is 54. Now, is that the lowest common denominator? No. Does it matter? Not really. I just have to be aware that I'm going to have to reduce later. Okay, so we're going to go ahead and stick with that, and then I'll show you another way. So 9 goes into 54. I did 6 times. So 6 times 7 is 42. 6 times 9 is 54. So 1 times 9 is 54. So now I'm going to subtract the top. 42 minus 9 is 33. Okay, now, again, this is where your divisibility rules come in. You look at this and you go, oh, 3 can go into both of those evenly because 3 plus 3 is 6 and 5 plus 4 is 9. So 3 can go into 33 11 times. 3 goes into 54, and you can use your calculator, 18 times. So now it's reduced. Okay, so if you just multiply the two denominators, that is completely valid. You are okay doing that. You just have to be aware that you're going to have to reduce it later. Okay. All right, we're going to go, let's see how much. Oh, good. We're almost done with this one. Okay, so this one, number 37, and then we'll take a break. Number 37, 15 and 20, I could just multiply, right? I get 300, I think. Yep, 300. I could do it this way. This totally works. I don't have to think about it. I multiplied the 15 by 20, so 8 times 20 is 160. I multiplied the 20 by 15, so 3 times 15 is 45. Yep, 45. And then 160 minus 45 is 115. Okay, so again, I can divide 5 into it. I could divide 3 into it. Oh, no, I can't, because when I add 5, 6, and 7, that 3 won't go into it. So 5 is what I can divide into it. So 115 divided by 5 is 23. 300 divided by 5 is 60. And since 23 is a prime number, I know I've reduced it as low as I can go. Okay. And then the last one before our break, again, even if there's 3 fractions, all I'm going to do is multiply. 3 times 5 is 15. 15 times 6 is 90. So my new denominator is going to be 90. Okay. Now, this is where the multiplying the denominators comes into really good play. 3 goes into 90 30 times. Well, look, 5 times 6 is 30. So I'm going to multiply the top by 30 on this one. 5 goes into 90 18 times because 3 times 6 is 18. So 18 times 4 is 72. And then 6 goes into 90 15 times because 3 times 5 is 15. So 15 times 5 is 75. And then I'm just going to add the top.
What did you
So-
multiply to get 90?
I did 3 times 5 times 6.
Okay.
Okay. Now, again, when I do that, because some people go, oh, no, you have to have the lowest common denominator. At the end, once you reduce everything, that will be the lowest common denominator. So you don't have to start with the lowest common denominator, you just have to end with the lowest common denominator. Okay, and then this one, this 177 over 90, 3 goes into 90, and look, 7 and 7 is 14, plus 1 is 15. So 177 can be divided by 3. So always, always, always check. Use the sum of the digits. So 3 goes into 177 59 times, 3 goes into 90 30 times. And then I am good to go. I just have an improper fraction. Okay. Any questions before we take our break? And we might even be done early today. We'll see. I shouldn't say that because then you get your hopes all up. Okay, so we're going to take a break. It's 12 o'clock right now. Come back at about 12:10, and then we'll finish the class. And then you'll have you get your first holiday. You've been in school a week and you get your first holiday. So I'll see you guys all back at 12:10.
I think you're still on mute. We can't hear anything.
Okay. Okay, let me start again. Sorry about that. Thank you. So when you're doing your place values, just remember to take a look at the zeros, right? In 1/10, there's 1 0 first place, 100th, 2 zeros second place, 1,000th, 3 zeros third place, and it just goes on from there. So 100,000 has 5 zeros, so it's in the 5th place. And that kind of gives you a better idea of what these place values are without having to, count them all out. Nothing wrong with counting them out, but it will, save you a bit of time if you just know, oh, thousandths is the 3rd place because there's 3 zeros in 1,000. Okay, and then real quick rounding issue, because in my math lab, you are going to be asked to round to the hundredths place, to the thousandths place, all of that. So just remember, if you're rounding to the thousandths place, so you look at the place that you're rounding to, right? That's the place that we're going to. And then the one next to it, to the right of it, is what determines if we stay the same or we go up. So the idea in rounding is if I had, 400 here and I had 500 here, 450 is right here, right? So anything between 0 and 4, your rounding place is going to stay the same. Anything from 5 to 9, the rounding place is going to go up 1. Okay, so those are your only choices. You don't get to go down. It's either stay the same or you go up 1. So if we're looking at the thousandths place, I'm looking at number 29. If we're looking at the thousandths place, I look to the right. The 1 tells me that the thousandths place is going to stay the same. So it's 0.581. Whatever place value you're going to is going to stay the same. Notice everything else gets dropped off. We don't care about anything else. All we care about is to the thousandths place. On number 30, we're going to the hundredths. So the hundredths, 2 zeros, so we're here. We look to the right. The 6 is between 5 and 9, so that's going to make my hundredths place go up 1, so 0.05. And all that means is 0.0465 is closer to 0.05 than it is to 0.04. That's all that means. It's just where it is on the number line, if you will. All right, and again, everything in front of where you're rounding stays the same. Everything behind it drops off. So number 31, to the tenths place, here's the tenths. We look to the right. The 2 says the 7 stays the same. So I have 8.7, everything else drops off. If it says round to 3 decimal places, 1, 2, 3, that's my 5. The 9 says it's got to go up 1, so it's 0.046. And then again, everything else drops off. Okay, so any questions, comments on rounding? Look at the place value, look to the right, and then the right number tells you which way you're going to go, up or stay the same. Okay, so now that we know place value, now we can change any decimal to a fraction. So we know this is the first place. That means the denominator is in the tenths, and the numerator is the number that you're looking at. Notice the decimal goes away. Right? It's not 0.4, it's 4 out of 10. And then you're going to reduce it. Simplify when possible. So these are both even. I can divide both sides by 2. So it gets reduced to 2/5. Okay. So when you're looking at more than one value, you always look at the last number. The last number tells you what your denominator is going to be. So the 9 is sitting in the hundredth spot. So my numerator is 29. So it's 29 out of 100 or 29 hundredths with the TH. And then again, the 7 is my last number. It's sitting in the thousands spot. So it's 117 over 1,000. And then I need to use my divisibility rules, right? So 7, 8, 9. So 3 can go into the top, but 3 cannot go into the bottom. So this is a simplified value. All right, so it's all about knowing your place values, being able to write a decimal to a fraction. Okay, and then when you're changing a fraction to a decimal, it's just division. That's all it is. It's just division. So number 36 is 19 divided by 6. So you can literally plug that right into your calculator. 19 divided by 6. So this is 3.16666, and it keeps repeating. And so if it repeats, then you're going to round to the nearest hundredths place. Okay, so it's repeating. So here's my hundredths. The 6 makes the 6 go up. So it's 3.17. Now, in your My Math Lab, wherever you have an answer box, usually there's going to be in blue, there's a little sentence maybe, or a couple words that says, you know, simplify your answer, or write as a fraction, or round to the nearest hundredths. So always, always, always pay attention to the blue lettering next to your answer box, because it's a computer program, it's only going to take the answer that it wants. So if it says round to if you have 3.166666 in your answer and it says round to the hundredths, it will mark it wrong. So make sure you pay attention to where they want you to round it to, or how they want you to write the answer. Okay, and then jumping to 38, you're literally top to bottom. You go 70, I'm using my calculator. 72 divided by 161 is 0.44724. It's not repeating, but they still want you to round the answer to the hundredths place. So there's my hundredth, the 7 makes the 4 go up, so it's 0.45. Okay, so there's repeating and then there's non-repeating. All it means is if you have a repeating decimal, it just continues the same pattern. Okay, all right, so order of operations when you're adding or subtracting fractions, exact same thing as order of operations when you're dealing with whole numbers. The difference is with the decimal, if you're adding decimals, you have to line up the decimal. If you're multiplying decimals, that part doesn't matter, okay? So when you're doing these, you're going to use your calculator. Just notice this is multiplication right here. So you're going to do this first in your calculator. Put that in first. And that way the calculator will do it correctly. Or the other way you can do it is 1.2 plus in parentheses. Let's see if it does it right. Hang on. Some calculators will do it correctly every time and some of them won't. It just depends on how they're programmed. I'm seeing if it's working right. Okay, so this is very interesting. When I did it the first time, let me erase this. I just did it exactly like this. 1.7 plus 3.7 times 4 minus 8.1. Got one answer. Then I did 1.2 plus parenthesis 3.7 times 4 close parenthesis minus 8.1, and I got 14.8. Make sure. Yep, 14.8. Then I did it using order of operations, and I did 3.7 times 4 first. Is 14.8 here. Oops, pencil here. Sorry, trying to get my pencil going. Okay, so I got 14.8 here. And then you go back to the front, just like what we did before. We have all addition and subtraction. So 1.2 plus 14.8 minus 8.1, and you get 7.9. Okay, so even though the first time I used parentheses here, the calculator still didn't do it in the correct order of operations. So don't be afraid to write things down as you go. Do the multiplication, get the answer for it, and then go back to the beginning and do adding and subtracting as you see it left to right. Otherwise, your calculator is going to give you different answers, and that's never a good thing. Okay. All right. So now converting a percent to a decimal. So a percent, all a percent is it is based on 100. That's all a percent is. It's anything out of 100. Okay. So when you're given a percent, this is actually 91 out of 100. That's what that percent says. It's 91 out of 100. You got a 91% on a test, 91 points out of 100 points. Well, when you change it from a percent to a fraction, then you already know how to go from a fraction to a decimal because it's just division. So if I divide 91 divided by 100, I get 0.91.
I have a question.
Okay? Yes.
For 40, would you multiply the parentheses because it doesn't have like a plus or a minus after the 5.2?
So here, yeah, what you would do is you would do the inside. So you'd go 2.4 minus 6.8. And so inside the parentheses, you'd end up with negative 4.4. Okay. Then you're going to multiply that by negative 5.2. And you get the 22.88. Then you're going to go 36.79 plus 22.88. So again, it's literally working backwards. You do parentheses, then you do multiplication, then you go back to the front and do your subtraction. And you get negative 13.91. Good?
Thank you.
Sure. Okay, so this whole converting from a percent to a decimal, I just showed you a very long way to do it, right? But I wanted you to understand why the decimal moves. The decimal moves because you're dividing by 100, not just because we're moving it, randomly. So anytime you're going from a percent to a decimal, you're going to take your decimal and you're going to move it twice. Because you're dividing, that number becomes smaller. Okay, so you take your decimal is next to the 1 because that's in the ones column, and you move it twice. So it becomes 0.91. But the reason that it moves twice is because you're dividing by 100. So if you ever aren't sure which way the decimal should go and you have a percent sign, just divide it by 100. So if I did 143 divided by 100, so 143 divided by 100, I'd get 1.43. Okay, so again, shortcut, take my decimal, move it twice to the right. Or take the number and divide it by 100. Any problems with that one? Okay, so now we're going to go the other way. Now we're going to go from a decimal back to a percent. So again, because we're dealing with percent, what we're doing is we're going, okay, we want it to be 24 times 100 this time. So when you multiply by 100, that takes you the decimal back the other way. So that's why I don't like to say right or left, because it depends on what you're doing. If you're going from a percent to a decimal, you move it to the left. If you're going from a decimal to a percent, you move it to the right. I would much rather you understand why are you moving it. If you're going from a percent to a decimal, you're dividing by 100. If you're going from a decimal to a percent, you're multiplying by 100. And this is you're dividing by 100. And once you have that concept, then you're good to go. You can just start moving your decimal point. 62.71, just don't forget the percent sign. Okay, and then this one, we move it twice. So it's 102%. Or 1.02 times 100. So it's just the opposite. You're just going in opposite directions. Okay. And so since you already know on 47, since you already know that you're going from 13% to a fraction, you know you're dividing by 100. So it's super easy to write a percentage as a fraction. And then it says don't simplify your answer, so we don't have to worry about reducing. 8 over 100. 77 over 100. Okay, and then the last few, and then the simplest form, you guys already know how to do this. I'll just do one of them. So this is 75 out of 100. We're going to reduce it by 25 each because quarters go into both of those. So 75 divided by 25 is 3. 100 divided by 25 is 4. There is your reduced fraction. So that is the percentage written in simplest form. Okay. And then being able to convert a fraction to a percent, all this means is you're going to go fraction to decimal to percent. And you guys know how to do all that. We've already done fraction to decimal. You've already done decimal to percent. So now we're just putting it all together. So 1 divided by 4 is 0.25. And you can either do it on your calculator or if you know that. And then we're going to move this twice and we get 25%. So it's literally just putting it all together. Number 55, 8 out of 25. So I'm going to go ahead and use my calculator. 8 divided by 25 is 0.32. Move my decimal twice and I get 32%. Okay. So where you would use this, you guys already saw this in your the Canvas orientation. I think there were 9 questions. Some of you, if you got an 8 out of 9, you could really quickly find your grade. 8 out of 9 is 0.888, and it keeps on going. So you move your decimal point twice, and you have 88.8%. Or if you're rounding it, 88.9%. Because the 8 makes the 9 go up 1. Okay, so you'll use this you'll use a lot. If you have, you love to shop, you go to the store, you have a 25% off, you can find out how much, how much the 25 out of 100 is 1/4, so you're getting a 1/4 of the price. Okay. All right, any questions on the fractions, decimals or percentages? Okay, so we are going to go into homework 3. So now you should be able to do homework 1 and homework 2. And by the end of class today, you should be able to do most or all of homework 3. So this again is just the developmental part. This is just kind of reviewing what it means to have an expression versus an equation and what combining like terms is. And so now we're getting into the algebra of this class. And so simplifying expressions, all that means an expression is just what I call a term. So 18 is an expression. 18 plus 5x is an expression. Anytime you have something that doesn't have an equal sign, that's considered an expression. If it has an equal sign, now it's an equation. Okay, so an expression, do it over here. An expression is, shouldn't use the equal sign. An expression is, come on, is no equal sign. An equation has an equal sign. And two very big differences. With an expression, you can't solve for a certain variable, right? An equation, we can get an actual answer, right? We can be able to go through it and we can solve for a specific variable. With an expression, it's just kind of simplifying it, making it look a little bit cleaner, maybe plugging values in and then being able to solve what the value is based on what you're given, which is what we're doing now. So anytime it says evaluate just means you're literally plugging and chugging out the answer. That's all it means. So when it says evaluate 18 plus 5x for x equals -4, the first thing you have to identify is when you have a number and a variable, a letter, that's an unknown. When you have a number and a variable together, that means multiplication. So what this is actually saying is 5 times whatever x is. Okay, so we know x is going to be -4. So now I have to use order of operations. I have to do my multiplication first. So 5 times -4 is -20. And 18 plus a -20 or 18 minus 20 is a -2. So once we plug a value in, then we can evaluate it and we can get an actual answer. And that's all evaluating is you take out whatever the variable is and you plug in what the variable means. Okay, so, thank you, Franco. Have a good weekend. Don't get hurt.
Okay, thank you. Bye.
Okay, bye-bye. Okay, so now A and B, all we're doing is we're taking out the A and B and we're plugging in the -1 and 3. So watch your parentheses. So A is -1, B is 3, but do you see these parentheses here? Means we're squaring all of it. And then -2 times whatever B is plus whatever A is. And I always like to put negatives inside parentheses by themselves because it separates it from the plus sign. Because you really shouldn't have a plus minus together without parentheses. Okay, so now I can change this so it'll be a little bit easier to read since we have parentheses already. Okay, so you can replace parentheses with a bracket. It still means the same thing if you feel like you have too many parentheses in there. Okay, so here we go, order of operation. Inside the grouping, -1 and -3 is -4. And I'm going to keep writing. So now I have exponents. So -4 squared is 16 because it's -4 times -4. I'm going to write it over here. This is number 2. Okay, so I just rewrote what we have there. So I have 16 and then a -2 times 3 plus -1. So I'm going to jump to my multiplication. So I end up with -6 here. So notice I'm always going to the back and rewriting, or I'm sorry, to the front and rewriting. I'm going back to the front and to rewrite it. So 16 minus 6 is 10, plus the -1 gives me 9. Okay. So order of operations is going to be key for this class. It's the foundation for everything that you're doing is your order of operations. All right, let me move this over and I'll do this. Okay, so number 3 says m is 8, n is 6, and we're multiplying them plus 2. And then we have the square root. So that's kind of a grouping symbol, if you will. You can think of it as a grouping symbol. So n is 6, and we're squaring it, minus p, which is 11. Okay, so it's just another order of operations problem. So we're going to do all the top. So multiply, 8 times 6 is 48. So we have 50 on top. On the bottom, I'm going to keep the radical. On the bottom, I'm going to do everything underneath the radical. So I have 36 minus 11. 6 squared is 36, and then minus 11. So 36 minus 11 is 25. So I have 50, and then square root of 25. So notice I just did everything underneath the radical as if that's a grouping symbol. And now I can answer. Square root of 25 is 5. So 50 divided by 5 is 10. Okay, so whenever there's a fraction and you have to do top and bottom, just do the top, do the bottom, and then at the very end, you'll do your division. Okay, so that's just evaluation. So now you're going to simplify the expression. So remember, expressions means there's no equal sign. So we can't find an answer for the variable. All we can do is kind of simplify it, put it together. I like to say clean it up, make it easier, simplify it down to one term. So what you're doing is you are multiplying, right? So you're going to multiply what's called the coefficients, the numbers in front of your variable. So negative 5 times 2 is negative 10. We still have an x. Okay, so I multiplied the numbers just like it says, and then my x comes down. Here, number 5, I'm going to multiply over on the side, Sophia. The one I did over here. Step out of the way. And again, if I go too fast and you miss it, you can always come back. This will be posted in the module underneath the homework that we're covering, and it'll say Zoom class and then the date, so you'll know which one to look at. Okay. All right, so we're going to continue simplifying the expressions. So negative 9 times negative 5 is a positive 45. So notice I'm kind of doing it in pieces, right? I'm doing the numbers, and then I'm going to gather my variables, my letters. And then m times n is just mn. Okay. And then decimals, I'm going to do the exact same thing. I'm going to go 3.2 times 7.4, which is 23.68. And then the variable just follows along. And then again, the fractions are still the coefficients, that's still the numbers in front, right? So we're multiplying, so I can do this on the side if it makes it more easy to see. So look, there's those big numbers again. I can do my cross canceling. So any top with any bottom. So 5 goes into 25 5 times. 5 goes into 35 7 times. And notice I know that there's a negative there. So I'm just going to hang on to that negative. And then any top with any bottom, 16 and 24. So 4 goes into 16 4 times. 4 goes into 24 6 times. And then I look any top with any bottom, and I can't do any more reducing. So 4 times 7 is 28. 5 times 6. Oh, I can reduce again. Sorry. I can reduce my 4 and my 6. So 2 can go into both 4 and 6 evenly. So 2 goes into 4 twice. 2 goes into 6 3 times. So just keep reducing as far as you can. But again, it's got to be any top with any bottom. Okay, now I can multiply straight across. So 2 times 7 is 14. 5 times 3 is 15. Don't forget your negative. We have a positive times a negative, which makes the whole thing negative. And then x times y is just xy. So anytime you're simplifying an expression, whether it's decimals, fractions, or whole numbers or integers, you're going to have to make sure that you can put it all together. All right, and then combining like terms. All that means is you are looking for the exact same thing. Same variable, same exponent. If they are different in any way, then they are not like terms. So like terms are same variable, same exponent. So for instance, on number 8, you have negative 10x and you have 8x. So think of it as the x is an item. I have negative 10 of this item and I have 8 of this item. When I put it together, I end up with negative 2 x's. Notice it's not x squared because x is an individual item. I have negative 10 of them and I have positive 8 of them. When I put it together, I have negative 2 of those things. Okay, and then a squared, a squared, a squared, those are all identical. The variable and the exponent is the same. So I can add my values. So I have 20 of them minus 7 of them, which is 13 of them. And then 13 minus 8 is 5 of whatever item it is, right? So variables is an unknown. We don't know what it is yet. We'll find out, but right now with the expressions, we don't know what it is yet. All we know is when I put it all together, I have 5 of them. Okay. All right, number 10, MN, MN, identical, right? If it was NM, that would still be identical because you can multiply and flip back and forth. So 2 times 3 is the same as 3 times 2. M times N is the same as N times M. So it's the exact same thing. So it can be flipped just as long as the variable and the exponent is the same. So I have negative 9.16 and a negative 1.32. So I have negative 10.48 MN. Everyone good? So obviously those three, all the variables are the same, right? We combine the like terms. So now look at number 11. Number 11, you have x, you have x squared, you have no x's, you have x cubed, x squared, x cubed, and no x's. So this is where the idea of combining like terms comes in. So I'm going to highlight all the like terms. So negative 4x cubed and 7x cubed, and notice I started with my highest exponent. Those are like terms. So I can add those together. So negative 4 plus 7 is a 3x cubed. So again, the x cubed stays the same. I have 3 of them. Now, I'm going to go to x squared. So I have negative 5x squared and I have negative 3x squared. So negative 5 and negative 3 is a negative 8x squared. Color coded here. And then I have x's, 11x, negative 11x. Those two are going to go together. So if I put those together, I end up with plus 0x. And I'm going to leave that there for a minute, and then I'll show you what we can do with that. So a positive 11 and a negative 11 cancels each other out. And then the last thing is I'm going to add my constants. So anytime you have a number with no x's, those are called constants. I'll write it over here, a constant. No variables. Just a number. Okay, those are called constants. So positive 1 and a negative 20 is a negative 19. Okay, so when something has a 0 in front, 0 times anything is 0. So I could rewrite this as 3x cubed minus 8x squared minus 19 because the 0x goes away. But the adding like terms, that is, you collect everything that's the same. Think of it as the Skittles, right? You collect all the red ones, you collect all the yellow ones, you collect all the green ones, right? And so you have 15 red ones, you have 2 green ones, and you have, 4 purple ones or yellow ones, whatever it is. So that's the idea of like terms. It's got to be the exact same variable and exact same exponent for it to be a like term. Okay, and then 12, you're going to do the exact same thing. You're still going to collect. So we have 3/5 y squared and 1/2 y squared. So all you're going to do is you're going to go 3/5 plus 1/2. So this takes you back to finding a common denominator. Multiplied the 5 by 2, multiplied the 2 by 5. And I get 11 tenths y squared. And then we have negative 16y and 7y. So we have a negative 9y. Okay. Any questions on combining like terms? Oh, how did I add the fraction? So the fraction was added by getting a common denominator, right? We had 3/5 and 1/2. So I multiplied my denominator just like I did before. So 5 times 2 is 10. So I multiplied the 5 by 2. So I have to multiply the 3 by 2. I multiplied the 2 by 5 and I had to multiply the 5 by, or the 1 by 5. Okay. Okay. All right, last little section. So now what we're going to do is we're going to combine what's called the distributive property and combining like terms. So the distributive property is just multiplication. But what you're doing is you're distributing, if I have this as my, I don't like using the same number. If I have this as my expression, right? Distributive property just means you're going to take the 2 and you're going to multiply it by the x. So 2 times x is 2x. And then I'm going to come back out, take the 2 and multiply by the 3. So 2 times 3 is 6. So I'm literally taking the outside and I'm multiplying it by everything on the inside of the parentheses. That's the distributive property. Some people call it distributive property multiplication over addition, right? So you're multiplying, and then you're adding the 2 terms. So that's literally all you're doing. You're going to take the 11 and you're going to multiply it by the 2p. So you get 22p. Then you're going to take the 11 and you're going to multiply it by the 7. And the 22p and the 77 there's no like terms. So you can't combine it any longer or anymore. It's already simplified, right? There's nothing to combine there. With number 14, you distribute. And again, there's no like terms, can't combine anything. Okay. Number 15, it's a little bit more. They're just kind of adding layers to it. So this 12 is separate from the 5. The 5 is what you're multiplying through the parentheses. So the 12 just sits there. The 12 just sits on the outside. So 5 times y is 5y. 5 times -3 is a -15. And now the 12 comes into play. Now we have combining like terms, right? We're going to combine our two constants. So 12 minus 15 is a -3 plus 5y. Okay, or you can rewrite it. It doesn't matter which order you write it in. Just make sure you carry the sign with the 3. Okay, so distributive. So number 16 is a little bit more, right? We're distributing this 5 through the 3c, we get 15c. The 5 through the 1, we get 5. Now, this is a little bit different, right? It's a minus 6c minus 4. Well, what that means is you have a -1 on the outside. Even though the 1 isn't there, it is a assumed 1 right there. So you're literally, and I like to say you're literally pushing that negative through the parenthesis. So you're multiplying -1 times 6c is -6c, and -1 times -4 is a +4. And now I can combine my like terms. I can combine my c's. 15 minus 6 is 9. And I can combine my constants. So 5 plus 4 is 9. Okay, yay, we're going to do it. Okay, last one. We're going to distribute. The 1/2 goes to the 8. And so this is how I look at this. What's half of 8? Half of 8 is 4. Half of 10 is 5. So I have 14n minus 4n plus, because a negative times a negative is a positive, and I'm going to distribute this -7, so -35. -7 times -2n is a +14n. And now I can combine my like terms. 14n minus 4n and 14n. So 14 minus 4 is 10, plus 14 is 24n. And 5 minus 35 is a -30. Okay, so distribute and then combine your like terms. Okay, and that's all of homework 30. Homework 3, sorry. Homework 2 is long. There's 20 questions, but they're short, quick questions. It's just practice changing, decimal to fraction, fraction to decimal, decimal to percent. It's real quick. So just get in there and knock it out. Okay? Any questions before you go? So today I'm supposed to have tutoring, a Zoom tutoring from Benny. Don't go anywhere. I need to talk to you since this is your first time in class. I want to make sure you got everything. I had a medical emergency in my family last night, and so I need to go take care of some stuff for my mom. So I will not be having tutoring now, but I will be on Zoom later tonight. So I will send out an email to or an announcement saying, hey, I'm on Zoom if you have if you have a question. Okay, so I will make it up. It's just going to be later on tonight, and I'll put an announcement in the class too. Sophia, what's your question? If you're good, if you're good to go, I'll see you on Tuesday. Have a great weekend. Be safe, you guys.
Thank you, ma'am.
You're welcome. Go ahead, Sophia.
Bye. Have a good weekend.
Bye-bye.
Thank you.
Bye, miss.
Bye-bye. Have a good weekend.
You too.
So Mia, let me look. It's homework. Homework 1 is due tonight. I'm sorry, tomorrow night. Homework 2, 3, and quiz 2 is due Tuesday, since Monday's a holiday. So yes, 1, 2, and 3 need to be done by, or 1 needs to be done by Friday. 2, 3, and quiz 2 need to be done by Tuesday. Okay. So that's why you don't want to wait till the last minute. You want to jump in there and get going. Let's see. Okay, I'm looking at the chat. Okay, so I got Mia. Is it Mia or Maya?
It's Mia.
Mia, okay. Okay, yeah, Sophia, I can't hear you. Let's see. So what would we need to do if we distribute 1/6? So 1/6 is just like multiplying fractions. So if I had, say I had 1/6 times x plus, 2/3, it would be the same thing. So we're going to distribute the 1/6. So 1/6 x, distribute the 1/6. So what that means is I'm multiplying 1/6 times 2/3. So I'm going to cross cancel. 2 goes into 2 once, 2 goes into 6 3 times, and I get 1/9. So it would be plus 1/9. Does that work? Okay. Yeah, I can't hear you, Sophia. You have to click the little mic. I think it's, if you hover at the bottom, it's at the bottom left corner. Okay. All right. So Benny, talk to me.
Yo, hello. How are you doing?
Hi. I'm good. How are you? Hang on. So 1 second, Benny. So Mia, a lab. What do you mean? Because you don't have like a lab that you have to go to. My math lab is the homework.
Okay, yeah, I just didn't know if it was like something else other than like the homeworks and quizzes that we have.
No, that's all. Just
Okay,
those.
okay, thank you.
Okay, you're welcome. Sorry about that, Benny. Okay, so Benny, talk to me, because I was going to email you today and say, are we dropping? Are we staying? So talk to me.
Yeah, that was my fault. I was a bit busy this morning. That's why I joined a little late. And then the last meeting, I'm not gonna lie, I just completely missed the last meeting.
Okay.
Yeah,
All right.
but I'm on it
That's
now.
not a good start.
I know. I'm on it now though, so.
Okay. Okay. And are you doing all the orientation module and you know how to get around in the class?
Yes, ma'am.
Okay. All right. So no questions for me?
I mean, shoot, how are you doing? How's your day going?
It's, life goes on.
Life is lifing. I feel that.
Yep. So, okay. So if you're good and you're in, I will keep you in class, but you got to have all those things done by tomorrow night.
Okay.
Okay.
All right, cool. That sounds cool to me.
Okay. All right. Thank you.
All right, thank you. You have a good one.
Okay. You too.
All right, bye-bye.